Introduction to Induction Cooking and Cooking Requirements. Garland's induction cooking equipment uses electromagnetism to heat the ferrous metal in a cooking pan via the induction coil, heating the pan and its contents without overly heating the surface the pan rests on. The technology is offered in a variety of models: single and double coil tabletop models, built-ins that have their components suspended below the cooktop. Modular units are used in kitchen islands, which require remote placement of the induction components. Units are available as griddles and woks, and the technology is used for holding warm food. In all instances, the electronic principle is the same. High-frequency magnetic waves rise from an induction coil and react with iron in the pan, cooking the food. The temperature of the heated pan is monitored by a sensor, shown in blue in this graphic. It is directly above the induction coil and directly below the pan, pressed against the cooktop's glass surface with springs. The heating is fast and energy efficient. Here, a liter of water is bubbling, ready to boil in 1 minute and 37 seconds on a 3.5 kilowatt unit. On a 5 kilowatt model, the boil time is faster. The unit reaches cooking temperature in seconds. Here, a pan's surface temperature is seen rising in temperature rapidly. Never heat a pan dry and never leave oil or butter to heat unattended. The pan and the cooktop can be damaged. Because the pan is part of the electromagnetic connection, pan selection and cookware care is critical. Some cookware is marked with an induction seal. However, not all pans with the mark are suited for commercial use. On some, the inductive material is a perforated sheet applied to the bottom. Others have ridges, which make them unsuitable for commercial cooktops. Pans must contain iron, and their bottom must be flat. Test them with a magnet and inspect for a ridge or distortion that will cause air gaps above the cooktop. Copper and aluminum pans can cause overcurrents, which can damage the unit. Non-magnetic pans won't heat at all. Pans must be sized for the cooktop in use. The cooktops are designed not to react to pans that are too small, smaller than 4 inches. There's not a similar protection for pans that are too large. The required pan size varies with units. Circles on the cooktop set the minimum and maximum sizes. Pans' do's and don'ts. Do use pans of the proper metal content. Do use pans of the proper size. Do place pans accurately on the cooktop surface. Do attend pans during the complete cooking sequence. Don't place pans across 2 cooktop coil fields. Don't place pans on the edge of a cooktop's coil field. Don't use pans made from unsuitable material. Don't use pans that are too large or too small. Such practices endanger the cooktop and will distort the pan, as the misplacement causes dramatic overheating in the portion of the pan bottom exposed to the magnetic field. The isolated heat buildup above the coil can distort the shape of the pan. The heat transfer to the cooktop damages the temperature sensor. Error messages are displayed and the unit can shut down. Installation errors can also harm units. Here, units are denied cooling air by being placed hard against a backsplash, and there's potential for further harm from steam rising from an adjacent water bath cooker. When internal temperatures exceed limits, power to the coil is reduced and an error is displayed. The 2 tabletop units shown here are in a recessed mount, which denies them cooling air. Successful operation requires a careful and accurate installation and proper cookware and cooking procedures.